Good morning, Kitty. First to comment, first to show up. I'm not gonna lie, I would never hear that in the classroom. No one is ever pumping their hands saying, "Yeah, I was the first one into the classroom at 9 in the morning." Hello, Ronald. Good to see you guys. Interact with you guys, not really see you guys. It's an expression. Let's see. Hello, Zanzib. Good morning, Joey. I hope you guys are having a good week. We're midway through week 3. Weather calmed down. Sure. It did. It's supposed to snow, at least in Buffalo, again this weekend. Although the middle of the country is, I don't know, I used to live in Iowa before this, and all of my friends in Iowa are like, we finally got above 0 degrees! And I'm thinking, I will take Buffalo weather. I will take the snow. I would rather have the snow than have negative temperatures, at least negative Fahrenheit. I don't even want to calculate what that is in negative Celsius. Your guys' homework is due tonight. Are there any pre-questions on the homework I can address? We've got 11 people here. At least that's what Twitch is telling me. So JC, that's a good question. So you're not gonna get much feedback in terms of where you got, like where you had errors. The solution is posted. So if you go to UB Learns, if you go to where you have the link to homework 1, you can find the link to the solution. It's just a PDF version, but you can compare it with your code. So you're not gonna get your code back in terms of like circles. It's just you can't circle code. It's just not possible. It's not like grading a Word document. But you'll be able to see your grade. Although unfortunately, there was an error in the homework solution I gave to the TAs and graders. So you're not gonna get your homework 1 grade back today, unfortunately, because of my error. I'm really, really, really sorry about that. I beat myself up about it yesterday. But if you plug it into Matlab Grader, you can see which ones you got wrong. And especially for homework 1, it's pretty much a 1-to-1 correspondence. Once we get into later homeworks, it's not always necessarily going to be 1-to-1. There are some limitations to Matlab Grader. But for the first homework, if you got green check marks on Matlab Grader, then you should get full points on your homework 1. But like I said, I made an error. And I gave the TAs and graders the wrong document. So you won't get your homework 1 grade back today. I hate when I make mistakes. I really do. I really hate when I make mistakes, because every time I make a mistake, that means that you guys have to deal with the changes and the issues and all of the repercussions of that. So I am not infallible. If you guys see something weird, please let me know. It might be maybe just a misconception on your part, but it really might be something wrong on my part. Okay. It is 9:10. Let us go ahead and begin. Quick question about homework. No, Danny, you're not going to lose points for too many parentheses. As long as you get the right answer, then it doesn't matter. There's multiple ways to program. There's multiple ways to get to the right answer. That's just preference in terms of programming. There's different styles that people have. Some people really like to use a lot of parentheses to clarify things, whereas other people don't necessarily want to use a lot of parentheses. Especially for long equations. I hate homework 1 because you have so many long equations and there's so many places where you guys can make errors. I mean, like I said, I gave them the wrong solution. I had many errors in my code itself, and I just never had anyone double check it, which is not a good idea. So there's just preference. There's really no formatting when it comes to how to write an equation. For homework 2, you're submitting 4 files. HW2P1 underscore UBIT name, HW2P2 underscore UBIT name, parabola, and torus. I do not need to know what you're going to input into the function. I will input stuff to the function myself. I will test your functions with my own values. You would just test your function with the command window, with another script file, however you prefer. But I do not need that test script at all. Just those 4 files. Okay, let's go ahead and begin and start doing more examples. So I'm going to start out, nope, wrong one. I changed it. I made it nice and fancy with my overlay. I mean, fancy is relative. I made it a little bit nicer. So on the top here, you guys can see on the top here, I don't know how people do that in their like YouTube videos and stuff. On the top here, you can see my notes. And then on the bottom down here, I probably look like an idiot right now. Down there is Matlab. And then, so we can see both. So just some quick examples. In Matlab here, I have A, D, and B created full of zeros. A currently looks like a bunch of zeros, but I want to put a 3, 37, and a 47 in the lower right corner. So if A is currently a bunch of zeros, it looks like this. I'm just gonna highlight, evaluate that. It looks like this, but I wanna change these last 2 numbers to 37, 47. So what I'm gonna do is I'm gonna say A. And now instead of doing all of A, I want to do part of A. So I type A, open close parentheses, and then I'm going to tell it which locations inside of A. So I want to change this location and this location. So this location is in row 3, column 7. So I can say row 3, column 7. I want to put the number 37. Similarly, in this last one here, in row 4, column 7, I want to put a 47. So now if I execute this, I now have a 37 and 47. That's one way to do it. Another way I could do it is I could say that I want to put numbers in row 3 and row 4. I can do it in one line. And I could say I want to put 37 followed by 47. However, keep in mind that the orientation of the numbers that you want to place should match the orientation. So if I want 37 to be on top of 47, I should put it as a semicolon. So now when I run this, same thing. So over here it says, where do I want to put things? I want to put things in row 3 and 4, column 7, which is row 3, row 4, column 7. What do I want to put there? I want to put there a 37 on top of a 47. So we have that's two sides of those equal sign again. Another way I could do this is I could use something called the end keyword. The end keyword indicates that it's the last column or the last row. So I could say end instead of 7 because 7 is the last column. So end automatically for A indicates the last column. So this would be the same thing. So that's 3 ways to do things right now. Another thing I could do is I could create an array with 3 and 4. So I could say 3:4 to indicate rows 3 through 4. This will give me the same thing. Since row 4 is the last row, I could also use the end keyword here. And this will give me the same thing. So I've noticed these last 2 lectures, last one and this one, you guys have been much less chatty, which is probably an indicator that this is information overload. It is. If you feel like I'm going through lots of examples, it's because there's just a lot going on here. This is the week where you really start to get into trouble with things. So there's lots of ways I can do this one example. So let me rewrite all of them. A37 is a 37. A47 is a 47. So here's where I do it independently, where I place these numbers one at a time. If you have to start there, that's fine. If you have to do one number at a time, that's fine. You will get better and more practiced as you go along. I could do this all in one line of code where I could say rows 3 and 4. Note that's in brackets. This is an array saying which rows. Column 7 equals 37 placed on top of a 47. So that's another way to do it. So here's 2 lines of code. Here's 1 line of code. I could use the end keyword. This does the same thing. End automatically identifies the last column in this instance for this array. I could also, rather than saying 3, 4, say 3 through 4. So all of these ways are the same way to change this, to make this a matrix here. To make this a matrix where it's full of zeros, where 2 elements are changed. All of that does the same thing. Okay, let's go on to D. So here's D. D currently looks like this. It's a bunch of zeros, 4 rows, 6 columns of zeros. And here in my document, I want to change this last row, these elements. So what do I want to change, or where do I want to store these answers? I want them to be in the D array. Not all of it, though. I want it to be in part of it. So I'm going to put in parentheses. And then which locations am I going to change? I'm going to change the last row. So here's row 4. And then these columns. So columns 3, 4, 5, and 6. So in row 4, columns 3, 4, 5, 6. Yeah, this would be the manual way, just stating out which ones do I want to change. So that tells me that's where I'm going to store some numbers. What numbers do I want to store there? I want to store 9, 7, 5, and 3. 9, 7, 5, 3. So now if I execute this, there we go. D has changed. I could do one number at a time. I could say in row 4, column 3, place a 9. In row 4, column 3, place a 7. In row 4, column 3, place a 5. In row 4, column 6, place a 3. But notice the more numbers you have to change, the more lines of code you have to write. So here it's much more efficient to do it all in one line of code. Notice I'm changing 4 numbers. I want them to be next to each other. So here I have 4 numbers next to each other. So the orientation and the numbers and everything that I'm going to change needs to match the same on the other side. And once again, there's multiple ways to do this. I could say D for columns 3 through 6. You'll see the colon operator a lot when it comes to identifying which rows and columns. Remember the colon operator, this is the increment. Oh, I didn't even mention that. Wow, I am so sorry. The colon operator looks like this. You start at this number, you end at this number, and this is your increment. Joey, for matrices, do you use brackets only for columns? No, you use brackets anytime that you are creating a matrix or an array, by anytime, really. I could have brackets around these. This is creating an array, starting at 3, incrementing by 1, ending at 6. So 3, then 4, then 5, then 6. You don't have to have brackets here, but you can. But you really just use brackets anytime you're creating a new array. I think that's what you may mean. So here I'm creating a row. Commas put things next to each other. So I'm using brackets. So a lot of times we'll see the colon notation. If you have an increment of 1, you don't need the increment. That the default is 1. However, if I did 6 colon -1 to 3, this would literally place it in row 6 or column 6, then 5, then 4, then 3. So this is also valid. Like I said, I don't feel like I really did justice of the colon operator for you guys on Monday. And part of that is just you'll learn as you go through the examples in your textbook. I don't know. There's lots of information this week. So 3 through 6. This indicates columns 3 through 6. Do we avoid writing too much code because it might slow things down? So, not necessarily. For Matlab, you're not really concerned about time in terms of execution, especially for something this small. Matlab is an interpreted language, which means every single line of code is individually compiled and executed individually. So I think if you do it in 2 lines versus in 1 line, I think behind the scenes, it's the same amount of code. Especially it's the same amount of time, same amount of compiling and execution. It's just for efficiency's sake in terms of here you have 2 lines to write, here you have 1 line to write. This might be a little clearer in terms of what your result might be versus typing it out 1 line at a time. And when you have small arrays, it's not that big of a deal. But a lot of times you're not dealing with small arrays in real life. You're dealing with big data, like big data, lots of sensor data from something. Like if you have a sensor that determines the amount of force applied, you're not really getting like a number every hour. You're getting a number every second. So you have lots of data. So this is just practice. Like I said, as you guys get more practiced in working with small numbers, small arrays, you will be able to extrapolate that out to bigger arrays. Okay, let's keep going. So there's lots of ways to do this. You could also use the end keyword as well, because 4 is the last row. You could say 3 to n because 6 is the last column. So there's lots of ways to do these things. Okay, let's move on to B. And then we'll move on to some other examples. So for B, originally, I just created a bunch of zeros. It's 4 by 5. So I initialized it with a bunch of zeros. And now I want to change row 2 so that it all contains the number 2. Okay, so once again, left-hand side, what do I want to change? Where do I want to store my numbers? I want to store them inside of B, not all of B, just part of B. So B, open close parentheses. And I want to change row 2. So row 2 and every single column in row 2. So I could say 1 through 5. I could say 1 to end. All of those are legitimate. The nice shortcut is just the colon, where just a single colon automatically behind the scenes MATLAB knows that means all of my columns. What number do I want to change it to? I want to change it to the number 2. The nice thing about if we set an array to a scalar, this scalar number is going to be copied and pasted into every single location. So that's the one caveat to where the number of elements on the left-hand side needs to be the number of elements on the right-hand side. The one caveat is if it's a scalar, it will copy and paste it into every location. So now, column 2 is all 2s. So that's the first thing I want to change. So I've got all of my 2s here. The last thing I want to change is this. I want to change my last column into 1, 2, 3, 4. So once again, I'm changing array B. I'm changing part of it, so open close parentheses. And I want to change rows 1 through 4, and then my last column. So I'm going to use end to indicate my last column. Once again, rows 1 through 4, I could say 1 through 4, 1 to end. I could also just use my colon to indicate all of the rows. For your homework, brute force things. Like, it doesn't matter. You don't need to have the most efficient way. Do what makes sense in your mind. If you're used to something, as you go along, you're like, okay, like, I know this. I know how to do things this way. Once you get used to that, someone might show you a trick in the future and you're like, oh my gosh, that's so much easier. Let me do it this way instead. And that's completely fine. That happens to me all the time. I'll see a new way to do something in Matlab and I'm like, that's brilliant. I wish I had known that a long time ago. But the thing is, it doesn't matter because there's more than one way to do things. You're not trying to write the most beautiful code. You're not computer scientists. You're not graduating. You're not graduates. You're not working in the field for 10 years. Like, you are beginners. It is okay to begin, to start with where you are at. So in my all rows, last column, I want to place the numbers 1 through 4. Let's see what happens if it gives me an error. Okay, this one does not give me an error. Matlab, hasn't always been like this. No, this becomes a row, 1 through 4. If I do this, it's just a row. Matlab, for some obscure reason, automatically converts the row into a column in order to place the numbers. Like I said, I don't know exactly what happens behind the scenes, but Matlab does something sometimes, and I'm like, stop! You're confusing my students! But this is just one of those instances where it's just going to place the first number, then the second number, then the third number, then the fourth number. Okay. We are 20 minutes into class, and I feel like I already overloaded you guys again. And we still have more to get to. I want to go through some of the challenge activities in Zybooks that you don't have to do, just to demonstrate some programming concepts. But key things from this morning is that idea of my left-hand side. Where do I want to store things? Ask yourself, is it an entire array? Is it part of an array? Which rows, which columns? If it's just a row vector or a column vector, you only need one number. If you have a matrix, you need two numbers, two sets of numbers. Which rows, which columns? Okay, right-hand side. What do I want to store there? Hopefully you can read my handwriting. As I'm talking, I hope it clarifies. What do I want to store there? Okay, so here I want to change 4 elements. Here I need to give it 4 elements. Unless it's a scalar, then it will be copied into all the locations. So there's a lot here. Part of it's just playing with it. As you guys get to your homework, you're going to just literally be creating a bunch of arrays and modifying them. So keep this in mind. Where do you want to store things? Is it an entire array? Is it part of an array? Which locations? Which rows? Which columns? Which elements? What do I want to store there? Am I going to store one number at a time? Or am I practiced enough to group them together? Okay. I'm going to... Okay, so I just wanted to stop here and just illustrate the colon operator for a minute. Like I said, I feel like I really failed you guys at understanding the colon operator. So the colon operator is just like linspace. They're both used to create linearly equally spaced vectors. So if I want to say I want to use the colon operator, let me zoom in on that. Use the colon operator to create this array. Notice this is my start number. This is my end. I could use linspace and just say start at 4, end at 13, 4 total elements. I could also use the colon operator by noticing that 4 to 7 is 3, 7 to 10 is 3, 10 to 13 is 3. So my increment is 3. So I start at 4, I increment by 3, and I end at 13. That's a good question. So Natchev, when it comes to, so there's the colon operator is used in 2 different instances. It can be used like this to create a linearly spaced array. This is when you are creating an entirely new array. It can also be used to represent all the columns, like here, or all of the rows, like here, when you are what's called indexing, where you are identifying which locations to change or access. So in this context, when you say B2, colon, this is the same as saying all of the columns. When you have B, end, this is the same as saying all of the rows in the last column. So this is where we have a lot of overlap in terms of the notation, where a semicolon here is used to indicate that 37 is placed on top of 47. This semicolon is used to indicate that you're going to suppress the output. So this colon here indicates that you are creating a linearly spaced vector with a starting at 4, ending at 13, with a spacing of 3. This colon here indicates that you're talking about all of the columns. This one here indicates you're talking about all of the rows. So I encourage you guys to like write down like different notations. Sometimes it helps to talk out loud what you are trying to do. Like I'm trying to change these rows, these columns, make them these numbers. So that's one way, and it's just practice. It's just practice. Sometimes you just have to do things over and over again, and you will get in habit. I don't know if this makes sense, but if you do multiple modifications, so notice I'm not running. I don't press run on this script file. I'm just highlighting and evaluating. It's a really good question, Zanzib. I'll get to that in a minute. I'm just highlighting and saying evaluate selection. Anytime you press run on a script file, it will automatically save in the Matlab program, not on Matlab Online. It's a little glitchier online. But if you press run, it will automatically save any changes you do and execute the code as it's shown. When you highlight it and right click, I'm saying evaluate selection. That means it's going to just execute the highlighted code line by line as if it was typed one line at a time in the command window. So it shows up in the command window. You can see I highlighted this. It shows up in the command window, executes this line, this line, this line, and prints out the output. Okay, so that's one array. Let's say I want to create this one. Same thing, I want to start at 14. I want to end at 6. So here I have to go 14 to 12 is minus 2, 12 to 10 is minus 2, 10 to 8 is minus 2, 8 to 6 is minus 2. So I would just type that in. Zanzib, I'll get to your question in a minute. So start at 14, increment by -2, and end at 6. So now when I execute this line of code, it gives me my array. If I had forgotten the negative, it will give me an empty array because it tries to start at 14. 14 plus 2 is 16, then 18, then 20, and it will never reach 6. So if it is impossible to start at this number and end at this number, it is going to give you an empty. So in Zanzib's question, it was, what would 0, 12, 4 look like? Same thing. Oh, it'll give me just give me a 0. So here it is possible to start at 0. It is a positive increment. It just never gets to 4. Whereas this one, it's impossible to get to 6. For this one, for 0, 12, 4, it starts at 0 and it gets as close to 4 as possible without going past. Unfortunately, the first number will be past 4, so it stops. Sometimes you just gotta try things. Sometimes you just gotta try it. You're like, okay, what happens when I do this? Oh, that's what happens. Okay, so that will give me that. But if you do something that's invalid, if it is impossible, like if it's never reaching the end number, never getting close to the end number, it is a empty. If it wants a column, you just transpose it. Transpose. So there's my transpose. So transpose is going to take, whoops, wrong one. Transpose is going to take your row and make it a column. Okay, that's a little bit on the colon operator. Yeah, sometimes you just have to try it. Same thing with debugging. So this is a really good tip. For debugging, I like to highlight and evaluate things one at a time, especially if you have like a long expression. Be like, okay, what if I just highlighted this section of my expression, executed it, and see what would happen? So highlighting and right-click, evaluate selection is actually a pretty good tip for debugging. Okay. Let's just pause there. Any other questions on some of this stuff? I like that you guys are asking questions. That means you're starting to think a little bit. Like I said, it is information overload. This is the part of programming where you're just going to have to try something and see what happens. Make a change, see what happens. Make a change, see what happens. Do that incremental. Like I said earlier, I want to go over some of your challenge activities from Zybooks. You do not have to do all of the challenge activities for chapters 3 and 4 for Monday. These are some sections you don't have to do. The rest of them you do. Most of them are in chapter 3, which are the easier challenge activities. Chapter 4 has some pretty hard challenge activities. So we aren't going to make you guys do those, but I still want to go through some of those just to illustrate some programming tips and how to approach programming, because you're starting to get to the point where you're starting to think like a programmer. So I want to go through some of them. I've never done Java. I'm confused on linspace and I. Linspace works the same as the colon operator. So if I wanted to recreate A with linspace, yes, ignore the activities that I have boxed in red. It shows in your textbook which ones you are supposed to do and not do. Linspace does the same thing as the colon operator. Linspace for 13. So I want to start at 4, end at 13. And now instead of identifying the increment, I just identify how many numbers. So I want 4 numbers. So these 2 lines give me the same array. Same thing here, B1, linspace. I want to start at 14, I want to end at 6, and I want 5 numbers. And then if I transpose it, I just do the transpose. So now these 2 give me the same thing. With C, I can't do the same thing with linspace because linspace always includes the start number and end number. The colon operator is just starts at 0, adds 12, and just stops whenever it goes past 4, whenever it equals 4 or past 4. The I function, it just creates a 0 matrix with 1's long diagonals. So I 4 rows, 5 columns. It just is all zeros. It starts at 1 in the 1, 1 location and just adds ones along the diagonal. We will get to I next week when we talk a little bit about and introduce linear algebra concepts. It creates what's called the identity matrix. So that's just I. It works the same way as zeros and ones. It just looks like this instead of all zeros or all ones. Number of rows, number of columns. Okay, let's get to, so activity 421. Good, I'm glad. Sometimes it takes, and to be honest, sometimes when you're programming, you just really need just a little explanation. Googling helps. Matlab has a lot of documentation associated with it. You can use some of those helps. So if you do linspace, if you type linspace up in this help, it'll give you the documentation. If you do help linspace, it will give you a brief description. So if you only give it the start and the end, it will automatically give you 100 numbers. If you give it start, end, and then the number of numbers, it returns that number of numbers. I like the documentation because it gives you examples. Okay, anyway, so let's clear and CLC. Okay, so in challenge activity 421, it's a function. So in your homework, you will have to write more functions. They're not going away. So once again, a function just, here's the input. So I don't know what square array is right now. Sometimes it helps to just choose a value for square array. So if I just said square array equals, and I know it's going to be a 3 by 3, rand I 10, 3, 3. Let's just say square array looks like this. It's just 3 rows, 3 columns. And there's more description in your textbook about what square array might be. But it's going to be a square array, which means it has the same number of rows as columns. And what this function is supposed to do is supposed to find the middle number. For a 3 by 3, that middle number is, so for a 3 by 3, that middle number is located, so let's call it A, that middle number is located at 2, 2. If I had a 5 by 5, that middle number would be a 3 by 3. If I had a 7 by 7, that middle number would be a 4, 4. So somewhere in my function, I need to do something. I need to calculate what this number is going to be. And notice it's the same on both sides. So it's always XX. So in my function, I need to calculate, if I have a 3 by 3, I need to figure out that I need a 2. If I have a 5 by 5, I need to figure out that I need a 3. If I have a 7 by 7, I need to figure out how to get my 4. So this is where some of those additional functions come into play. So in the notes, remember we had the size function, we had the length function, we had the numal and dims. Some of these are some useful functions to use when you're trying to detect, I guess is what you could say, when you're trying to ask the array for some information about itself. So if I have square array, I can ask square array how big it is. How many rows do you have? And remember, I can do that with the size function. So I want to know the number of rows. Then I can say, hey, size, SQARE, array, and then in the first dimension. So tell me how many elements you have, how many elements you are in the first dimension. So Nicole, for a 3 by 3, the middle number here is 7. This is located in row 2, column 2. So that's why it's 2, 2. For a 5 by 5, it looks like this. The middle number is here. It's in row 3, column 3. If I had a 7 by 7, the middle number is here. It's in row 4, column 4. So all of these are completely valid options for square array. So a lot of times in programming, you're not going to know how big something is going to be. You're not going to know if square array is a 3 by 3. Is it a 5 by 5? Is it a 7 by 7? So a lot of times we're going to ask it, which is where we use these functions. So this size function here, I am asking my array, how big are you? How many rows do you have? Whatever number that is going to be stored in R, or I could call it rows, or whatever you want to call your variable. So if the number of rows is 3, I need to somehow get to 2. If the number of rows is 5, I need to somehow get to 3. If the number of rows is 7, I need to somehow get to 4. If you notice, that number, that middle element, is always going to be rows divided by 2. So 3 divided by 2 is 1.5 plus 1/2. 5 divided by 2 is 3.5, or 2.5, plus 1/2 gets me to 3. 7 divided by 2 is 3.5, plus 1/2 gets me to 4. So that's one way we can do things. So square array exists in my workspace here. So I'm going to go ahead and highlight these 2 lines of code, say evaluate selection, and see what it gives me. So it gives me, if my square array is 7 by 7, I can see that it gives me a 4. My element index is 4. This is one way to do it. Another way you can do it is using what's called your rounding functions. So CEIL is ceiling, so that you could do CEIL rows divided by 2. So if we highlight that, notice that also gives me 4. You could also use the round function, which I believe will also give me a 4. You can do the floor function and then add 1. So this will also give you 4. So there's lots of ways to do things, and that's generally true in programming. There's lots of ways that you can do things. So here there's 4 ways that I showed you. You can just do the original way where you just add 1/2 to rows divided by 2. You can use some of your rounding functions. Floor, which puts it down, ceiling, which puts it up, and then round, which goes either way depending on what your value is past the decimal point. So that is definitely an option. Thank you, Tidy, for recommending or for mentioning that. Okay. So sometimes you just have to try something. Sometimes it helps to go through examples. Like I wrote out here on the piece of paper up here, what if I had a 3 by 3? What's my middle value? What if I had a 5 by 5? What's my middle value? What if I had a 7 by 7? What's my middle value? Recognizing those trends. So Matthew, that's a good question. For this challenge activity, it says assume square array is odd. So that's why I'm only working with 3, 5, and 7. So now I can figure out what my middle index is, what that middle row, middle column is, and now I can actually get it. So I would do square array, and I want to grab the middle row, middle column. So keep in mind, I don't know what square array is. If you are having troubles figuring out what your input is going to be, choose something. Choose square array to be a 5 by 5. Create a random array, manually put in numbers. But notice inside of here, I'm working primarily with my variables. I know that rows is going to store however many rows my array has, regardless of what square array contains. I know that element index is going to store whatever number of rows divided by 2 plus 0.5. I know that middle element is going to store whatever that middle element is in the rows, whatever that middle element is in the columns of square array. So we're starting to get a little more complicated in what you guys have to do. The key thing is identifying what can your variables store. So there's a lot more going on here. You're starting to get into programming, logical, how to design an algorithm, which is the hardest part of this class. Because if I asked you guys to just use these line by line, you'd be like, okay, yeah, I can do that. But if you have to think about how to do it yourself, that's where the challenge comes in when it comes to programming. How do I do this process in a logical way using all of the tools that I know? That's where it's challenging. Could you go over what this line 10? So line 10, I'm using the size function. And there's multiple ways to use a size function. I went over this on Monday. This is one of the ways where I'm saying I want to identify for this array how many elements there are in the first dimension, which is the number of rows. Rows is first dimension, then columns, then 3D, then 4D, then 5D, etc. So rows is going to store however many rows square array has. You could do the same thing for columns because it's the same number of rows and columns. I technically could do this, but I'm asking, hey, array, how many rows do you have? Whatever that number is going to be stored in this variable. So now I can use that number, whatever it stores, in any calculations. So I can take that number, divide it by 2, add 0.5. Okay, let's get into GenMat border. So there's no description here, but essentially this challenge activity from 4.5.3, like I said, you don't have to do this one. I'm just going to use it as an example. In mat is just any array. So let's say in mat equals rand I, max value of 10, 4 rows, 7 columns. So let's say in mat looks like this. What this function is supposed to do is supposed to put zeros in all of the borders. So row 1, column 1, and then my last row and last column should all be zeros. So that I'm left with just the inside. So for this one, if I want to make the first row zeros, I'm going to say in mat, row 1, all columns equals 0. So if I do this, highlight it, whoops, evaluate selection, now my first row is zeros. Let's say I want to make my first column zeros. In mat, all rows, first column. So now here's my first column. All of my rows, first column, make it equal 0. Remember, if I have a scalar, that means this scalar number is going to be located in every single position. So now my first row and first column are zeros. If I want to make my last row zeros, in mat, last row, all columns equals 0. So now that would make this entire row zeros. If I want to make my last column zeros, in mat, all of my rows, last column equal to 0. So now if I execute this function, if I call this function from my workspace, say a equals genmat border, rand I 10, 3, 6, it gives me an error. It says output argument outmat, and maybe others may not be assigned during call to genmat border. So if you remember when we write a function, inmat is we're gonna do something with inmat. We're gonna do something with our input. We need to assign our output something. So my last step here, and you'll probably run into this when you're doing your challenge activities, a lot of times you'll forget to assign your output variable something. So my last step here is gonna say outmat equals inmat. That would fix that error, but that's what that error means. Output argument may not be assigned. It means you forgot to assign your output a value. So now if I rewrite this, I have zeros everywhere. If I change the size of my matrix, same thing. It's always going to be the first row, first column, last column that are set to 0. I could technically do this all in one line of code. No, I couldn't. I can do this in 2 lines of code. I'll let you guys figure out how we can do that. But doing it in 4 lines is completely legitimate. Let's see. Let's do this one. So this will be our last one. I'll make it bigger. I didn't want you to change that. Whatever. So what this function is supposed to do is it is supposed to delete this row, delete this column from this matrix. So let me go ahead and do that. So here is my new matrix. Here's my deleted elements. So in my original matrix, I'm going to delete this row and delete this column, which not that difficult. Where new matrix, well, let me just delete them. So org matrix A. If I want to delete this row, I don't know which row it is. Let's just say del row contains a value of 3. It doesn't really matter what it contains. Just use it as if you know. So if I'm going to delete that row, that means I would delete that row, all of the columns equals empty. If I want to delete this column, same thing. Let's just pretend del col equals 2. If I want to delete column 2, I would say org matrix A, all rows, and then column 2. Instead of a 2, though, I'm going to use my variable, del col. There we go. And then once again, new matrix is going to be set to org matrix A. So now my new matrix is going to be my original matrix with this row deleted and this column deleted. I also want to keep track of what my deleted elements are. So that means before I delete them, I need to go ahead and store them in a different matrix. So my deleted row is equal to my original matrix that original row. I also want to keep track of which elements I deleted from the column. So I would say deleted col equals org matrix A, all rows del col. So once again, it's not as straightforward. No one tells you necessarily, well, in your textbook, it does tell you, it gives you hints on how to do things, but it doesn't necessarily tell you how to do things. So you kind of need to figure it out as you go along. Make up an example. So if your original matrix is 3, 7, 5, 2, 1, 4, 6, 9, 8, and you want to delete this row and this column, you know your final matrix should look like this, 3, 7, 6, 9. Where you can easily delete this and easily delete that using these two lines. By just setting that row to empty, setting that column to empty. You started there. If you want to keep track of the fact that you deleted this row and deleted this column, that means that before you delete them, you need to store those values. So you want another place to say that, hey, I deleted 2, 1, 4, and I also deleted 5 and 8, where the 4 was already deleted. So this is your final matrix. This currently is my deleted row. And this is my deleted column. The colon operator to delete all of the rows or columns. Yes, so here it means for the given row, let's say it was row 2, all of the columns, delete the entire row. Here, same thing. In column 3, delete all of the rows, so delete the entire column. You can't delete individual elements at one time, it will give you an error. So you can only delete a single row or a single column. Doesn't matter if the value 4 is stored in the column or row. So sometimes when you're writing a function, you just need to assume that the user knows what they're talking about. You can't delete row 4 because row 4 doesn't exist. So if my matrix, okay, so A looks like this, it's 6 by 7. If I try to say for all rows, column 7 equals empty, it will tell you matrix index is out of range for deletion. So sometimes you will get errors. A lot of times when you write functions, you just assume that the user knows how to use it. This is a challenge activity, so the function template is already given for you guys. You will have to write, I think, 2 functions in homework 3, where you will have to write them from scratch. Just like with homework 2, we give you what your function definition line should be, so what your inputs and outputs are. But you guys need to figure out essentially how to do things. It helps to write things out. If you are stuck, write down an example. Pull out a sheet of paper. What if original matrix looked like this? What if I wanted to delete this row? What if I wanted to delete this column? What does that look like? So the last thing for this problem that I need to do is I just need to say that deleted elements contains my deleted rows plus my deleted, I'll transpose that, my deleted calls. So now if I run this function, say A, 3, 5. So now this is my new A, where I deleted row 3 and row 5, and these are the elements I deleted in my B. I transposed deleted rows because deleted rows is a row. It's a row, it looks like this. And deleted columns is a column, it looks like this. So if I want to stack them on top of each other, I need to transpose this so it also is a column. If I didn't do that, it would probably give me an error. It would give me a dimension mismatch error, where it's trying to put a row on top of a column, and that doesn't give us something square. Whereas if I transpose this, it will place the column on top of the column. So pay attention to your errors. I know we're out of time. Pay attention to your errors. They give you some indicator of what's happening. If you have a dimension mismatch, or dimension of arrays being concatenated or not consistent, in line 19 here, it tells me, oh, this is incorrect. Use that highlight. Highlight and evaluate selection. Identify, what does this look like? What does this look like? What happens when I put it together? If you have other errors, matrix index is out of range for deletion. Matrix index is out of range. That means you're trying to access a location. You're trying to modify a location. Well, you can modify locations that don't exist, but you're trying to do something with a location that you can't do something with. Output argument may not be assigned. That means that somewhere you did not say that your output equals this. Okay, so your errors in Matlab are better, I think, than errors I've seen in other programming languages. So try and get used to them, try and understand them. In general, they will tell you what line it exists at. However, it won't do that if you highlight and click selection. But you guys will figure it out. Okay, with that, sorry it took so long. Hopefully this helps. We will see this throughout the rest of the semester. So you guys will get practice as we go along. Any final questions before I hop off and jump into office hours? Okay, have a great day. I believe in you guys. You can do this. You just need to sit there and play with it a little bit. Don't be afraid to try something. Also, don't be afraid to go to office hours. Don't be afraid to... I've seen some really great discussions on the Discord. Yeah, just try something. Okay. With that, have a great day. We'll see you all guys. See all of you guys next week. We can do it. It's week 3. Halfway there. Just keep moving forward. Okay, I gotta run to office hours.